Hello Year 9, this is your lesson on parallel and perpendicular straight lines. If two straight lines are parallel, then they have the same gradient. And conversely, we can say if two straight lines have the same gradient, then they are parallel. So here we've got a line that passes through the points A and B. We've got a line that passes through the points P and Q. We're asked to show that they are parallel. So first we are going to find the gradient of the line segment AB. Remember, we find gradient with y2 minus y1 over x2 minus x1. So in this case, let's say this is our x2, y2. This is our x1, y1. Remember, it doesn't matter which way round. Just I'm going to be subtracting and these numbers are bigger, so it's going to be easier for me. So I have 11 minus 4 over 7 minus 6. 11 minus 4 gives me 7. 7 minus 6 gives me 1. 7 over 1 is just 7. So the gradient of the line segment AB equals 7. Let's have a look at PQ then. And again, it doesn't matter which one is the ones and which one is the twos. These numbers are bigger, so it's going to be easier if I put those first. So this is for AB. For PQ, I'm going to have 7 minus 0 over 1 minus 0. That equals 7 over 1, which is 7. So I've got the same answer as I calculated the gradients for both line segments, therefore the lines are parallel. Now, this is slightly different from the question I just went through, but for question 1, you need to state which of these are parallel. So remember that in the normal form of a straight line that we use here, y equals mx plus c, m is the gradient. So, for example, in question C here, my gradient is the coefficient of x, the number multiplying the x, which in this case is negative 2. If you have an equation like b, d, g, and f, where y is not the subject, remember, by itself, then you'll need to rearrange it to have in the form y equals mx plus c, so you can identify what m is. I pause the video while you do that and then make sure you're checking your answers. Okay, in this example, we need to find the equation that's parallel to this line and passes through this point. If it's parallel to this line, then I know that my m, my gradient, must be equal to the same thing. So I know that m equals negative 2. Then remember, the way we find the equation of lines when we have the gradient and a point is y minus y1 equals m times x minus x1. My m is my negative 2. My coordinates here, x1 and y1, are there. So let's just substitute those in. Y minus 10 equals negative 2 brackets x minus 1. Now I'm going to expand the brackets. Be careful, I've got negative 2 times negative 1. Then I'm going to add 10 to both sides. Now, it doesn't tell us to leave our equation in the form y equals mx plus c, but you should do that because that gives you the most information unless you're told otherwise. Pause the video now while you have a go at questions 2, 3 and 4. Okay, now a reminder, perpendicular straight lines are lines that meet at a right angle. That's what perpendicular means. If two lines are perpendicular, then the product of their gradients is -1. Remember that product is the answer to a multiplication. The only time when this isn't the case is if you have one vertical line and one horizontal line. If you remember, vertical lines, their gradient is not defined. And horizontal lines have a gradient of 0. So we can't multiply something that's undefined by 0, but a vertical line and a horizontal line do meet at right angles. The converse of this is if the product of the gradients of two lines is -1, then the lines are perpendicular. Let's have a look at how we can use this. I'm asked to show that the line through the points A and B is perpendicular to the line through PQ. So let's start by finding the gradient of the line segment AB. So I'm going to state my formula, y2 minus y1 over x2 minus x1. Oh, don't put y first. Let's make this x2, y2, x1, y1. So I have 12 subtract 0 over 0 subtract 6. That gives me 12 over -6, which is -2. Now let's work out the gradient for PQ. Now here, the coordinates in P, so here I had a larger number for y2 and a larger number for x1, so I was going to end up with a negative regardless. For PQ, I've got larger numbers for P than I have for Q, so that's the bit of my screen that doesn't work, but let's call P x2, y2, and we'll call Q x1, y1. So I've got a half there. Now I need to multiply these together. So -2 multiplied by 1/2 equals -1. So I've shown that the line segment AB is perpendicular to PQ. And I can say, I didn't do this before, I can say, so AB perpendicular, so I do like an upside down T and an R perpendicular to PQ. And really what I should have done back here when I proved, when I proved that these were parallel, I should have written AB parallel to PQ. Okay, so pause the video now while you have a go at questions 5 and 6. With question 6, similar to the previous question, remember when Y is not the subject, you need to rearrange the equations to put them in the form y equals mx plus c. Let me do an example to help you with question 5. If I had a gradient of L1 equals -1/3, then I know that the gradient of L1 times the gradient of L2 is equal to -1. So that's -1/3 times L2 equals -1. I divide both sides. Well, you can probably work out what that is. Can you work out what you multiply -1/3 by to get to -1? It's 3, isn't it? If you want to show each of the steps in your working, we divide both sides by negative 1/3. That's negative 1 divided by negative 1/3. Remember, when you divide by a fraction, you multiply by its reciprocal. So I've got negative 1 times negative 3, so that equals positive 3. You don't need to show all of those steps. If you can work it out in your head, that's fine. Okay then, so remember you need to pause the video while you do question 5 and 6. Okay, so in this example, we've got a point that our line passes through and it's perpendicular to the line y equals 2x plus 1. So first I need to work out what my gradient is. So I know that 2, that's this 2 here, times the gradient of my line, which is m, equals negative 1. So I can divide both sides by 2, and I get that the gradient of my line is going to be negative 1/2. Then remember, to find the equation of the line, we use the formula y minus y1 equals m times x minus x1. I've got my point here. So I just substitute all of the things I know in. Now I expand the brackets. Got a negative times a negative, so be careful there. Then I add 3 to both sides. I can just say plus 3.5 or 3.5 is 7/2. Now that's perfectly acceptable, but sometimes you might want to write this without having any fractions. So I can multiply everything by 2. I could write it like this, but I'm happy for you just to leave it in this form. If the back of the book does something different, then you can check with your teacher to see if you've got the right answer. So now you can do questions 7 and 8. For question 8, drawing the diagram is really important. Then, if you have time or you'd like to challenge yourself, you can have a go at questions 9 to 15. Make sure you mark your work and ask if you have any questions. Thank you.